Thank God, bro. I don't like exiting. Okay, so we're looking through question 4 right now. So let's say um so we only have one pair of positive integers a and b such that this thing is true. Now I have to find the sum of a and b. So how would we approach it? Like, do any of you have any ideas? Just like
Well,
no.
I only have one like thing I could. It's not too big.
What'd you figure out?
It's like a squared. I mean, a to the power of a times b to the power of b is more than a to the
Uh,
power of b times b
yeah,
to the power of a.
yeah. All right. Okay. Yeah. Okay. Yeah.
I'm pretty sure B is bigger than A.
How?
Yeah. No, you just because like this is because like this thing is bigger than this thing. Wait. Is it?
But then a could be bigger than b.
Yeah. True, true. I don't know. Like maybe. But okay. So how would we approach this? Well, I think for me, like when we see these powers, I kind of just want to match up these powers since, it's easier to deal with.
I just match up power.
But okay, so what we do is we have 16 a to the a, b to the b is equal to at1, a to the b to the a. So basically, my first thing I wanted to do was like, all right, we know these are constants, so we'll just move them over to one side. I'll move all the like power stuff onto the other side, just to make it like easier to deal with. Maybe, yeah. So what do we get? We get 16 on 81 is equal to a to the b times b to the a on a to the a times b to the b. So like it's might be not easy to see. So let's just swap around the denominator. We get that a to the b times b to the a. It's equal to a to the b on b times b to the a on b to the b times a to the a. And why is this important? Because like if we separate them, we get a to the b on b to the b times b to the a on a to the a. And we can see this is equal to
Yeah, you're not giving them enough time to process the steps.
okay, yeah.
No one's followed you up to the third step, yeah? So this is not routine. They don't know algebra, okay? So
Alright. So how much can they process? Because like
well, first of all, maybe Marvello can explain
yeah.
why is the first step true? Is it 16 or 81 equals a to the b times b to the a, or what happened there?
Because it is because it is.
Like, what was done? They did two steps in one go there.
Hmm.
I had to.
I feel like it'd be more understandable if like you did something like okay, well I mean you can explain you're dividing both sides by 81.
Yeah.
And then you're dividing both sides by a to the a, b to the b, yeah?
Yeah. Yeah. Oh, I do take these things for granted, yeah.
But what's wrong with like cancelling out the a's there? So if like
Hard because A to the A and B to the A, the different. So, because A and B are different, the A, the power A, will change because it's the power. So, the number which you will change the A to the A or B to the A will change. So it doesn't mean that it means you can't cancel it out.
What? But you said B was bigger than A, right?
Yeah.
Yeah, so if there's AAs and BAs, you can cancel the AAs and the BAs, right?
Usually can't, because if B is bigger than A, then there'll be more B's because it's.
No, I'm talking about the A's.
Yeah, A to the B,
BAs.
A to the B, and A to the A.
It's like if you do A, there are A amount of A's, but if you do BA, then it's the A amount of B's.
I'm not talking about that. I'm talking
Oh.
about how many A's there are, you know?
Yeah,
There's B on the right hand side and there's A on the left hand side.
yeah.
How many A's there are?
Yeah, there's AAs on the left, BAs on the right. Yes?
Yeah.
I'm suggesting to cancel those.
Oh, okay.
Yeah.
That's a more natural first step, right?
Mm-hmm. Yeah.
Also, you might be a bit reluctant to make a fraction of 16 or 88.
Yeah.
Especially when we're in positive integer land.
Well, like to be fair, like this was my first step. I just like sent them and then tried to see what happened. But it's because like it's more so like the left hand side. We know we don't need to do anything with the left hand side, and we can just like work with the right hand side and eventually try and get something. But no. You know the A. Yeah.
Alright, so do you know how to cancel it, Ernest? Wait, so in your things, you just not cancel it? You just make it A over B to the
Yeah.
power of B minus A?
Yeah.
Well, it's the same anyway.
Yeah.
It just doesn't make sense, that's all.
Oh yeah.
I don't know, like,
Yeah.
I could be wrong. Like, Ernest, do you actually follow the algebra?
Like
Because the thing is, like,
yeah.
when the kid says they follow the algebra, that's probably worse than when they say they don't follow the algebra.
Yeah, that's true. Like it's more like you avoid like negative indices more because I'm not 100%. Yeah. 100% sure they'd understand that. So
Yeah, so there's AAs on the left, there's BAs on the right.
yeah.
B is bigger than A. We can just cancel the AAs. Does that make sense? Ernest? Like you have 2 to the power of 4 and then 2 to the power of 6. You can cancel 4. You can make 2 to the power of 2. Yeah?
Yeah.
You can cancel 4 of the 2.
Yeah.
Can I just check?
So like in general, so if we have A times A times
Get rid of the A to the power of A, and then you do A to the power of B minus A.
Yeah,
Yeah.
exactly.
A to the B minus A.
Yeah.
Right. Okay. So okay, let's do that then. So we get that we cancel like we cancel the AAs with like we cancel the AAs on the left with AAs on the right, and then we're gonna be left with B minus AAs. So we're gonna get 16 times B to the B is equal to 81 times a to the b minus a times b to the a. So
Wait, can't you just do it with the other side as well then?
yeah, you can also do it to the other side.
So it's 16 times b to the power of b minus a
Yep,
equals 81 times a to the power of b minus a.
yep.
There you go. Right?
There we go. Right.
See, that's the natural thing to do next. Right? Just did it once.
Yeah. Do we make it a fraction? Do we put into fraction or?
I find the idea of putting it in fractions kind of abhorrent.
What?
Some word that I could spit out.
No, like as in now, like move stuff around. Like I personally be fine with that.
Really?
Yeah, because like the powers make it like the powers like
I feel like,
Yeah.
I feel like the next natural step is to like 3 to the 4 divides 8.
you might say. Yeah, sure.
At no time were there fractions ever needed.
What? No, I would
You're
not
the one
do
who
that.
crossed out numbers and said positive integers.
Yeah,
You made a commitment.
yeah, but like you get rationals, and rationals work nice. Like let's be real.
Anything that's not irrational.
A rational is a fraction.
Yeah. So what would you do here?
What would you guys do? So 16 is actually just 2 times 2
Yeah.
times
Oh
2
yeah. We do that. Yeah.
And 81 is actually 3 times 3 times 3 times 2.
Yeah. We do this thing. Is equal to 3 to the 4 times a to the b minus a. Yeah. Like, so what would we do here? What would we do here? Wait, Ernest, what would you do here?
Cancel it, like the b minus a.
Not really. No. What would you do? Do you have any ideas?
Can we do like 81 minus 16? Is
Why
can we
minus?
just
Why 81 minus 16?
because that amount will be the difference between
No,
a.
should it not be divide then? If we're gonna do that, would it not be divide? Yeah, it should be. So you're going for.
Oh yeah,
Yeah.
I think so.
I guess if you don't really know what to do, like I'd say, all right, we know that like if we look at this thing, we have a power, we have some twos here, right? We have some threes here, and we need so since there's twos here, we need some twos in our A, and we need some we need some threes in our B. So like I know this doesn't work, but let's see what happens when we do B equals 3, A equals 2, just to see what happens, right? So b equals 3, a equals 2. So we get 2 to the 4 times 3 to the 3 minus 2 on the left, and we get 3 to the 4 times 2 to the 3 minus 2 on the right. So what is the issue with this? Like basically our power of 3 isn't big enough, our power of 2 isn't big enough. So what would that motivate? So how would we increase our powers? basically.
So, does it mean that B and A are at least 2 apart? It's otherwise it's going to be times 1 into the power of 1. So
Okay, so actually, I'd say so basically, what's the issue with this? So I think, yeah. So what is the issue with this? What is the issue? Not big power.
Where here? Where did it go?
Yeah.
Like at level 1.
Yeah. Where? I'll take it down.
Yeah, so what's the issue? We don't have big enough powers of 3, we don't have big enough powers of 2. So what are 2 ways to increase those powers? We have 2 ways. So one way is to just like change our 3 to a 9, which is like 3 squared, or 2 to the 4, which is 2 squared. That's one way. Our other way is to increase the values here, so that means that our powers will be bigger. So generally, let's just say, oh, instead of a 3, let's put a 9 here. Then what will happen?
what?
So let's say instead of a 3, we'll change b equals 3 to b equals 9. And let's see what happens. Because now,
Sure.
yeah, it won't work. Because we've gotten too big. Right? So maybe now we think about it, maybe we do want our b to be like 3-ish, right? So
Yeah, so can you see like this 3s and 2s, the 2s have to come from somewhere, right?
Yeah.
2s have to come from the b's, yeah? And the 3s have to come from the a's, yeah? And obviously there has to be other stuff, but all the other stuff has to be in both A and B, yeah?
Yeah. So whatchamacallit? So like, yeah, we can't really make our b like really that much, like really, we can't really make it a higher power in a sense. But how do you describe this? Wait, how would you describe it? Because like the only way I can, the best way I could intuit it was with a fraction. Like,
A and B both have some common primes that
oh yeah,
just purely cancel, right?
oh yeah, oh yeah, that's actually how you describe it. So we know that, yeah, there is some like 3 in B, and we note there's some 2 in A. So maybe we let B equals 3 times something. Let's let it be K. Oh wait. Maybe, yeah, we let B equals 3 times K. We let A equals 2 times K. And then when we have and then when we power them, since they're the same power, the K's will cancel. Right? Could we see how we'd motivate that? Because how do you describe it? Because it's like 2 to the 4 times, if b is 3 times k, it's going to be 3 times k to the b minus a is equal to 3 to the 4 times 2 times k to the b minus a. And then you can remove this k to the b, you can like expand the brackets, and you get 2 to the 4 times, actually no, rub this out. You'd get 2 to the 4 times 3 to the b minus a times k times b minus a is equal to 3 to the 4 times 2 to the b minus a times k times b minus a. And you get these two things cancelled, basically. So I guess that kind of motivates you to put it in this form. So b is 3 times k and a is 2 times k. So do we kind of get it or not, really?
I think it's okay not to get it because it doesn't actually make that much sense.
Yeah.
It could still have like B could have 2's in it, A could have 3's in it.
Yeah, and then just they cancel. Yeah. And it's like, yeah, that's why I was more inclined with to like do it with the fraction because it's 2 on 3, 2 on 3 to 4.
Biased because you're comfortable. It's not
Yeah.
like logic. I
Yep.
guess you can do a fraction. If you're comfortable doing a fraction, you can.
Yeah,
It,
because like left side is fraction to a power and right side is fraction to the power,
yeah,
and then
you
you're
can
trying.
compare it.
Yeah, that's like what I was going for. So, so how would we say it? Like,
So write the equation to the 4. So just that blue. Keep the blue one off. So raise it.
yeah, yeah, to the 4 times b minus a. Yeah,
But in that equation, can you see you can divide both sides by 3 to the 4? Yeah.
wait,
So if you divide both sides by 3 to the 4,
yeah. So
and the whole point of doing this so there's no 3 to the 4 on the right, okay? Because if it's timesing by 3 to the 4, dividing by 3 to the 4 will get rid of it.
yeah. So we get this. Wait.
Yeah.
So yeah, do we see this?
Then you divide by b to the b minus a.
Yeah, and then you divide by b to the b minus a, and you do b to the b minus a, and this is divided b to the b minus a, and you get 2 to the 4 on 3 to the 4 is equal to a to the b minus a on b to the b minus a. And you can see with these exponents, since they're the same, we get this is the same as 2 on 3 to the 4 is equal to a on b to the 4. I mean a on b to the b minus a. Right. So basically we get this. This is what our equation is equivalent to. Can we see it? Do we understand how we got there? Wait. So do we understand how we got there or not? Wait, Ernest, you get it or what? Like, do you understand how we got from this to this?
Oh, yeah.
Yeah. And then since it's 2 to the 4 and 3 to the 4, we can just like take the power out. Same thing with a to the b minus a, b to the b minus a. So you can see this, right?
Yeah.
So we kind of just like look at this. For them to be the same, right? Let's look at it. If they're the same, we get b minus a. If b minus a is 4, and a on b is equal to 2 on 3, then they're going to be the same, right? Because then this is 2 on 3 to the power of 4, basically. Yeah. Is that too light? Can you see it?
I can barely see it.
Okay.
I can see it.
Okay, I'll put it in orange. So basically, we got 2 on 3 to the 4 is equal to a and b to the b minus a. So if we have a on b is equal to 2 on 3, and we have b minus a is equal to 2 minus 3 is equal to 4, then we get their equal, right?
Yeah.
So we just solve for this, basically. Right?
Okay.
And what do you get if you do this? Yeah, you get 12 and 8. So you get that b is equal to 12 and a is equal to 8.
So that's 20.
So you get a plus b is 20. Yeah.
Uh,
So you understand at least this bit.
you said that was like shorter compared to the other one.
Yeah, like the thing was like with this up to here, like I wasn't sure. It's like I wasn't really sure like if you'd like 100% get this.
Oh, they're going 100%.
Yeah.
You can be 100% sure they don't 100%.
Yeah, exactly. So, like I'm pretty sure you don't 100% get this part. So I didn't want to
But
like.
that's okay. It's better to not 100% get something you don't like. You actually